What we learned about vector and scalar quantities. Now, the next step in A.1 is to learn about kinematics and using Suvat equations, as well as learning about projectile motion. So, Suvat, characterized by the 5 variables in the acronym, are you have S, which is the displacement measured in meters. You have U, which is the initial velocity measured in meters per second. V is the final velocity, also measured in meters per second. And acceleration is measured in meters per second squared, and time measured in seconds. As you can see, 4 of these quantities are vectors, and only time, the last one, is a scalar quantity. And that means that you'll have to factor in the direction as well. It's displacement, you can think about just the distance from, you can think about it as a distance from a given point, but also factoring in the vector, so the direction vector of it, whether it's positive or negative. And the rest are fairly self-explanatory. You can calculate these variables using the Suvat equation that you have in your data booklet. For the first one I like to refer to as VUAT, or V equals U plus AT, and that is just final velocity equals initial velocity plus the product of acceleration and time. The other one I like to refer to as Suvat, and that's just the displacement equals the one half the sum of the initial and final velocities multiplied by the time. Next one I like to refer to as SUTAT. Displacement is equal to initial velocity times time plus one half of acceleration multiplied by time squared. And the last one, VUAS, the V squared equals final velocity equals initial velocity squared plus 2 and product of acceleration and displacement. You should be able to identify which of these equations best fits for the question depending on the values that you're given. You'll be given, for example, the time or the initial velocity, or it'll be implied. Sometimes when it says an object starts from rest, that means that the initial velocity is always equal to 0. And from then, once you have your variables sorted out, you can isolate and solve for the variables that they ask you to. Now, projectile motion just refers to the motion that occurs over 2 dimensions, which means that there's a horizontal component and there's a vertical component to the velocity vector or the displacement vector or any vector describing the motion. And you can calculate the horizontal and vertical components separately using Suvat equations. Typically for horizontal, you can even not have to use Suvat. You could sometimes just use the most basic formula, velocity equals distance divided by time. But in these situations, when you have graphs of the y and the x dimensions, and you're given a certain vector of acceleration or velocity or of acceleration or of displacement, to find the horizontal component of it or the vertical component of it, you just simply use trigonometry. Typically, you'll be given the magnitude of this vector and an angle. You'll be given an angle. And using basic right triangle trigonometry, as you can see, this will be equal to the vertical component, and using SOHCAHTOA, that would just be equal to u sine theta. The y component is equal to u sine theta. And the x component of u, using SOHCAHTOA again, this is going to be u cosine theta. And another important detail is the acceleration due to gravity on Earth's surface. It's a constant that's in the formula booklet, the first constant that you'll probably learn, and it's 9.8 meters per second squared. Whenever you're given a question where an object is falling, or an object is is moving vertically, you can always consider the acceleration to be, the acceleration is always a given, and that's 9.8, the acceleration due to gravity. And that's it for kinematics.